Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSC Department. Today I am going to deliver a lecture on transaction processing, which is part of DBS subject in AKGEC being studied by CSIT student in 5th semester. The code of this subject is KCS 501. So our topic is transaction processing. So what we are going to study is outline is what is transaction. Second, the properties of the transaction that are basically known as asset properties. Third, transaction state diagram. Fourth, schedule. So these are the various points that we are going to discuss. So first of all, we should be aware with what is transaction. So I am going to discuss what is transaction all about. So transaction we can say is basically it is a sequence of operations that are performed as a single unit of work. Means it is a collection of different operations that are performed together to perform certain work. A transaction contains one or more SQL statement. Example of transaction is, here we have given example that we are reading a value, then after read operation we are deducting 50 from A, then we are writing the value. So what the purpose of this read operation? This read operation basically fetches the value from the disk into the buffer. So the read operation fetches the value of A from here to here. Thereafter we will be performing local write operation. We will be modifying the value of A not in disk, but instead the value is being written here, that is being updated here, A minus 50. Then after performing the write operations, the value is being updated in the disk. So write operation, after the value is being updated, the value has to be reflected in the disk. That is the function of write operations. These two operations are very critical operations that are used in transaction. So then next is, we are also reading a value of another data item B. Then we are transferring 50 amount from A to B, then it will be B plus 50. Thereafter write B command is being executed. Why? Because we want to update the value in the disk from the buffer. So these are the operations that are being performed here. One is subtraction, other is additions. So these are various operations that are being performed in this transaction. So whole of this transaction is working like a single logical unit. Now what is asset properties of the transactions? So A stand for atomicity, C stand for consistency, I stand for isolation, and D stand for durability. What is atomicity? Atomicity means either the transaction execute completely or it does not execute at all. We don't want partial execution, that some of the operations are successful or other are not. Means either task should be 0% or should be 100%. Partial execution means also failure. So it is either 0 or 1 in terms of digital. Second property is consistency. Consistency means the database must remain in correct state even after the transaction as it was before the transaction. Before the transaction, the database was in consistent state. So after the transaction also, the database must be in the consistent state. Next is isolation. Isolation means that the transaction must be unaware of the other transitions that are running parallel to it. It is mainly a property to be implemented in concurrent execution, because in serial execution only one transaction execute at a time, So isolation, we need not to worry in that case. But when multiple transactions are working at same moment of time, then we need to ensure the property of isolation. Here, intermediate transactions results must be hidden from other concurrently executed transactions so that the problem of concurrency does not arise. Last property is durability. Durability means that once the transaction has completed successfully, the changes it has made into the database must be permanent. That is, it must be reflected in the disk. Once it is done, then we say it is committed. Thereafter, we are going to discuss atomicity first. Atomicity means the system must be treated as one single atomic unit, that is indivisible unit, like atom. So it is indivisible unit. Either all the operations are successfully executed or none are. Means either it is 0 or 100%. For example, we want to transfer rupees 50 from account A to account B. Then the transaction is written as like this: read A equal to A minus 50, write A, read B equal to B plus 50 and write B. Here it is 0%, and if the last line is being executed, then it is 100%. Suppose we are here, suppose it is 50%. So this 50% is also equivalent to 0. This 50% has no value at all, it is also 0. So it will be considered as a failed one. If failure occurs here, it is 0. Only after the last line is executed, we can say the transaction has successfully executed and it is 100% performing the task. Then consistency. Consistency means the database must remain in consistent state. That is, what is consistent state? Consistent state means the database must remain in correct state after the transaction as it was before the transaction. In our example, where we have deducted rupees 50 from account A and transferred it to account B, thereafter the total amount must remain same before the transaction and after the execution of transaction. Let us demonstrate it with the help of example. Suppose the initial value of B is 500 and A is also 500. So the total here it is shown is 1000 before the transaction. Now after the transaction is over, what is the value of A? It is 450. And what is the value of B? That is 550. So the total value is 1000. If the total value after the transaction remains same as it was before the transaction, we can say the property of consistency has been maintained by the transaction. Next is isolation. Changes occurring in a particular transaction will not be visible to any other transaction until it has been committed. All the other transactions are not aware what that particular transaction is doing. That is, the intermediate transactions result must be hidden from other concurrently executed transactions. In our example, once our transaction start from first step, its result should not be accessible to other transactions until its result should not be accessible to other transactions that are running parallelly. We are discussing the isolation. Changes made occurring in any particular transaction will not be visible to any other transaction until it has been committed. Intermediate result must be hidden from other transactions that are being executed concurrently. In our example, once our transaction start from step number 1 that we have written, then here we are not going to access the result. Other transactions will not be able to access the result. Other transactions will be able to access result only when the transaction has completed. Means these things are being hidden till the last time. Next is durability. After the transaction completes successfully, the changes it has made to the database persist even if there are system failures. Once our transaction has completed up to the last step that we have shown in the previous example, its results must be stored permanently in the disk where the data reside actually. The data reside in disk. So, the result must be completely shown in the disk. Only then the inconsistency problem can be solved. It should not be removed even if the system fails. So, these are the final values of A 450 and 550. When these values are reflected in the disk, then we say that the property of durability has been maintained. Next is transition state diagram or state transition diagram. As we see, like a process, transition is like a process which undergoes various stages in its journey. So, what are the various stages of the transitions? Active state, partially committed, committed, failed, and aborted. Now, let us discuss these all the phases one by one. This is the initial phase. When the transition starts, we say the transition is in active state. The transition remains in this state while it is being executed. Next state is partially committed. When the final this operations is being performed, right operation is performed, when final operation is being performed at this particular moment of time, we say the transition is partially committed. After this state, partially committed means the last operations has been executed. The transition is in partially committed state. Now, committed, the transition enter in this state after the successful completion. We cannot abort or roll back a committed transitions. Basically, transition is committed state. When it is in committed state, when the values are reflected in disk. When the values are being reflected in disk, we can say the transition has committed. Failed state, when the normal execution can no longer proceed, we say the transition has failed. Failure may be due to a variety of reasons. It may be a logical error, it may be a error related to operating system, it may be a system error. So, various type of errors may corrupt, due to which a transition can fail. So, it can no longer proceed. Once the transition cannot be completed, any changes that transition has done in the database must be changed back to the previous consistent state, so that the property of the consistency is being maintained. Aborted state, after the transition has rolled back, then the database has to be restored to the previous consistent state before the starting of that particular transitions. Now, transition can also, now failed state can arrive directly from active to failed state or from partial committed to failed state. Suppose here the transition fails, then the transition will jump from here to failed state. If the transition is failing here, it will jump directly to the failed state from the active state. Or when this last line is being executed, after the execution of the last line, the transition fails, then it will jump from the partially committed to the failed state. and the transition will finally end in two ways. Either it is committed or it is aborted. So, the final journey will end when it is either committed or it is being aborted. So, we can describe active state as the initial state, that is the transition state in this state until the transition is being executed. Next state we have already discussed, that when the transition executes its final operations for the instruction, it is said to be in partially committed state. Next, failed state discovers that the normal transition can no longer proceed, then we say the transition is partially, it has no longer been performing the task that it is desired, it is no longer proceeding further, we say it is in failed state, that the operations are being failing. Transitions cannot be completed and any change that it has made must be undone, rolling it back. Committed, we have done that it enters into this state after the successful completion of the transitions, that is the committed state has been entered. We cannot abort or roll back a committed transition. So, we must be very careful. If the commit operation has been completed, then we cannot make any change in the database. Once the operation has committed, so the values will remain permanent in the disk and we cannot make any changes. Abort it, the state after the transition has been rolled back and the database has been restored to state prior to the start of the transitions. Now, next is schedule. Schedule is basically the grouping of the transition into one and executing them in a predefined order. That is, it is a schedule is basically, we can say it is a chronological ordering of the in which the instructions are being executed. For example, a simple example of schedule in our day-to-day life is what we do daily. We make a plan out for this. That is a schedule for that particular day. In related to class, we have the exam schedule, we have the timetable schedule. So, a order is being there and we have to follow that. That is the basic purpose of the schedule. Here also in transitions, a schedule means we group together that all the transitions into one and execute them in predefined order. So, the schedule is the chronological order in which the instructions are being executed in the system. Schedule is required because when some transitions are running parallel, they may affect the result of the other transitions. Means if one transition is updating the value which the other transition is accessing, then the order of these transitions will change the result of the another transitions. So, that is a very critical thing that we have to consider. Hence, a schedule is created to execute the transitions. Example of schedule. See, this is the example of a simple schedule where there are two transitions, transition T1 and T2. Transition T1 is reading a value of A and updating it. Thereafter, transition is reading a value of B and completing it. The transition is being completed. Thereafter, another transition T2 start. This transition, what it basically does is, it is reading the value of A. Thereafter, 10% of A. Then, what is the updated value of A is? A is A equal to A minus temp. Write A, then read B, B equal to B plus temp, write B and then committed. So, here one transition is completed. This transition is being completed and after the completion of this transition, other transition is being executed. So, this type of execution is known as serial execution. In serial execution, first one transition execute, only after the completion of one transition, another transition will start. So, this is how this schedule will work out. Initial value of A and B are 1000. So the initial value read is this one. Then the value of A becomes this 950, 1000 minus 50. Thereafter, the value of B is being read as 1000, and then the value of B become 1050. Finally, this value is being committed. So the value of A and B are now 950 and 1050 at this particular moment. So the transition T2 will be reading what value? 950 and 1050. Here the value of A is being read as 950. Then the value of temp is 950 into 0.1, that is A equal to 950 minus 95. Now the final value of A becomes 855. Thereafter B is being read. So what is value of B is being read? That is 1050 is the value of B being read. Now the value of B equal to 1050 plus 95. So this is the final value of B. Now we must check whether the property of consistency has been maintained or not. So what is the final value is 1, 1, 4, 5 and 8, 5, 5. So this is 0, this is 0, this is 0, this is 2000. So the total after the transaction has committed is still 2000, and initial value of A and B was 1000, 1000. So its initial sum was also 2000. So the property of consistency is being maintained as the final value remains unchanged. So this is another example of a schedule whereby transaction T1 is executing, thereafter the transaction T2 is being executed. Similar values of A and B is being shown here. So we are studying serial schedule where only one transaction start at a particular moment of time, and after it complete another transaction executes. So the transactions are basically executed one after another. These are the examples of the serial schedule we already studied. This is the serial schedule where T1 start, after it complete T2 start. In another schedule, first the transaction T2 complete, thereafter the transaction T1 is completing. So these are the example of serial schedule. Only one transaction is being executed at particular moment of time here. Not all the transactions are being executed at particular moment of time. Next is non-serial transaction schedules, that is concurrent schedules, interleaved schedule. See here the second transaction start before the end of first, and we switch between these transactions to back and forth. This is also known as concurrent schedule. We can also say it is concurrent schedules. Another terminology for this is concurrent schedule. So here we have the interleaved execution of the instructions. Example, here in this particular example, first we read the value of A in transaction T1, A equal to A minus 15, then write. Now this has not been completed, T1 has not yet been completed, then T2 starts. Now some of the instructions of T2 are being executed. Some of the instructions of T2 are being executed. Thereafter, after the execution of all the information of data item A, then we start the execution again of T1. Here we are reading a value of A and updating the value of A. Now this transaction is over. Thereafter we start with this. So the whole of this thing is that the execution is being taking place in interleaved fashion. This is also example of another non-serial schedule, or we can say concurrent schedule. Here first schedule T2 start, then we have some of the instructions of T1, then we have some of the instructions of T2, and then we have some of the instructions of T1. Now equivalent schedule. What are equivalent schedule? If the two schedules produce the same result after the execution, they are said to be equivalent schedule. They may yield the same result for some value and different result for another set of value. That is why equivalence is not generally considered a very significant parameter. Consider these two schedules. Both of the schedules are equivalent because the final value of A and B here also and here also. Final value of A, this will provide the final value of A. This will also provide the final value of A, value of B. Here we are getting the final value of B, here we are getting the final value of A. Here, since this is a serial execution, this is the final value of these two will provide the final value. And if these final value are same, we can say that transition are having the equivalency, that is both of the transitions are being equivalent. So the reference that we have is we have quoted from Sudarshan and Silversach. Then we have taken the help of Navathe. Then we have taken some reference from Raghuram Krishna, and we have taken some of the reference from J.D. Illuminant. Thank you.